Okay, let's summarize what we discovered in the last two videos. We said that if you have a capacitor, this is, for instance, a parallel plate capacitor. So all you're seeing here is a cross section. The capacitor plate itself is coming out of the page. So this plate has positive charge, this plate has negative charge. These are the two conductors in the problem. This region has an electric field then going from the positive plate to the negative plate called E node. Now, this is the situation before you insert the dielectric material. When you insert the dielectric material, and we showed in the previous two videos, it doesn't make a difference whether the material initially was polar or non-polar. It doesn't make a difference. The net effect is that you're going to get some negative charges sticking out of the dielectric material on the left with no positive charge from the material itself to cancel it, and this charge, we call it minus sigma induced, and you're going to have some positive charge sticking out of the material on the right with no negative charge of the material itself to cancel it out, and we call this sigma induced. And this positive sheet of charge, this negative sheet of charge, will make their own electric field to the left, called induced electric field. And so it doesn't matter whether the molecules initially were polar or non-polar, it doesn't matter. The net effect is this, that you get a reduction in the electric field inside the material. So since the electric field has decreased, then the potential difference decreases. And the charge on the capacitor plates, the conductors, stays the same because we never connect these conductors to any kind of circuit or anything. So during the insertion process, this conductor and this conductor keep their charge. So Q stays the same. Since Q is the same and delta V gets weaker, smaller, then the capacitance increases. And this is the intuitive understanding of how inserting a dielectric material, in the case where the charge on the conductors remains constant, how the capacitance changes. It becomes bigger. This is the intuitive understanding of that.